Hey, probability and stats kids. This is Dr. Callahan with Week 16 Tuesday. How are you guys doing? Go ahead and pause the video and answer the following three questions. Okay, let's go ahead and get started. So this is your answer for question number one. All right, the answer is 60. The number in the center of the triangle is multiplication of all of the numbers in the corner, and that's how you get that. So 4 times 3 times 5 is going to give you 60. All right, so today you guys have two worksheets or two set of a worksheet that we're going to be working on. This is the first one, and it looks like this. Okay, so use the nearest neighbor algorithm to find the Hamilton circuit from D. So yesterday we talked about the brute force method and then also the nearest neighbor method. So if we're going to start from D, which is right here, you're going to look at, okay, so from D to E, D to F, D to A, D to B, D to C, which one is the cheapest route? And you should notice that from D to A, it is going to be 7, which is actually the best one because anything else is either going to be 10, 15, 12, 13, or 7. So 7 is the best. Then you look at from A. A to F is 9, A to E is 8, A to B is 16, A to C is 13. Which one's the shortest route? It will have to be E. So A to E is going to be 8. And then do the same thing. E to F is going to be the least expensive route because if you look at from E, E to F is 2, E to B is 14, E to C is 5, E to D is 15. So the least expensive route is F, E to F. And that's going to be 2. Then looking at from perspective of F, it will be F to C, then C to B, then B back to D. So this is your total. You're going to add everything together, and your grand total here is going to be 35. All right, next one. A band is planning a concert through 10 cities, including their hometown A. The distances are given in the chart. So as we look into this right here, here is the nearest neighbor tour. You have all of the first circuits starting with A to A, B to B, C to C, all the way to K. And then, of course, inside, you go ahead and you rotate the different variations of the number. And then these are the total length. So like, for example, A to C is 119. C to E is 120. E to D is 199. D to B is 150. B to J is 379. G to K is 235. K to F is 222. F to H is 211. H to A is 277. If you go ahead and add everything together, your total length is 2153. So your goal here is to find the lane that has the shortest route or the shortest amount, which in this case is this circuit, and it's 2033. All right, so it is logical that some more than Hamilton circuits that we track, the better chances of finding the circuit that is closest to the most optimal answer indicating that it has the shortest amount. The nearest neighbor method is dependent on the vertex you start off with. So if you start with a different vertex, you will most likely get a different answer. So remember, you can rewrite any circuit so that it starts with a different reference point. With 10 vertices, there are 10 minus 1, which is 9 factorial. So 9 times 8 times 7, 6, 5, 4, 3, 2, 1. 362,880 possible circuits, including the mirrors. And the table shows you the nearest neighbor tour found from each vertex. So you're really only looking at 10 different tours. And the 10 different tours are the 10 right here. And really, we only found 5 because you are doing the mirror images of these as well. Here is the repetitive nearest neighbor algorithm. So we're going to start off x being any vertex, find the nearest neighbor with x. Repeat the process with each of the other vertex starting with x. Choose the tour with the least cost. So for example, if I were to apply this to Willy Loman, I'm going to start off with A. Okay, so A is right over here. And I'm going to go from A to C because that is the cheapest route. And then from C, I am going to go to E, which is the least expensive route. From E, I could either go to D, I can go to B. I will go to D because that's the least expensive route. Then from D, I must go to B because that's the only one left. And then from B, you go all the way back home to A. When I add everything together here, it is 773. So if I were to go ahead and redraw this and rewrite this, I will have, here's A, B, C, D, E. And the route that I'm going for is from A to C, C to E, E to D, D to B, and B back to A. Another form that I can do is if I go backwards. So if I were to go backwards from this, I have A to C. Actually, I'm going to go from A to E. In this direction, it's A to E. E to D, D to B, B to C, and then C back to A. Another one that we can do is if I start with A, I go C, E, D, B, A. Now, if I decide not to start with A and I decide to start with B, then my route could be B, A, E, D, and then back to B. Then if I start at C, according to this part here, find the nearest neighbor tour with X as a vertex, calculate the calculate the cost of this tour, repeat the process with each of the other vertices of the graph as a starting vertex. So if I start off with C, from C, which one would be the least expensive route in this situation? I can go to C to A, C to D, C to E, or C to B. Well, C to A will be the least expensive route. And then from A, I can go from A to E, A to D, A to B, but E will be the least expensive route. And then E to D, D to B, B back to C. If you calculate this, this is your same amount. I want you guys to pause the video, do that for D and E. So your D, you should have D, B, C, A, E, D, which total up to 722. E, C, A, D, B, E, which totals up to 741. So looking at this one right here, which one is the least expensive option? So if I were to rewrite this, I will go from B, C, A, E, D in this direction. Pause the video and do that for C, D, and E. All right, let's take a look over here at the back side. Okay, use the repetitive nearest neighbor method to find a Hamilton circuit and its weight. So if I start with A, I go to A to B, which is the least expensive. B, I can go to D, which is 2, C, so I'm going to go to B. And then from D, I am going to go to C because that's the only one I haven't gone to yet. And then from C, I go back to A. Now let's do the same thing with B. So from B, I can go to A, which is the shortest method. From A, I go to D, which is only a 3. From D, I'm going to go to C, which is 4. And from C, I go back to A. I'm sorry, from C, I go back to B, which is 7. Then if I were to do this from C, which one's the least expensive route, go to D. From D, the least expensive route is to B. From B, I can go to A. And for A, the last one I can go to the C, and then C back to. And actually, that's it. So same thing with B, comparing this, which one's the most optimum route. Let's do the same thing with example 2. So from A, the least expensive route is to go to E. From E, the least expensive route is to go to B. From B, the least expensive route is to go to C. From C, the least expensive route is not to go to E because I've already been there, but is to, let's see, A, E, B, C, and then I can either go to D, which is be the least expensive route, which is 7, and from D, I want to go back to A, which is 6. Pause the video, do that for the rest of the points B, C, D, E. All right, next thing I want you guys to do is go ahead and insert your student interest survey. Go ahead and fill this part out. If you're doing this at home, you can go take a look at it and just write it down. Okay, next we're gonna go over the next example, which is right here. So let's go ahead and try to do this with a V, W, X, Y, Z using this chart. So go ahead and pause the video and do the questions here. All right, let's take a look at the answers. Obviously, the best one is the one starting with X. So then if you have the rewrite from Z, you want to start with Z, X, V, Y, W, and then stop. Back to Z. Because the home is from Z, you start at Z. This is the most optimal one. So you start with this part here and just include X, V, Y, W, and then back to Z. All right, now that we're done with this part, I want you guys to go ahead and pause the video and answer the following questions when it comes to the brute force method. All right, you guys, I hope you have a wonderful week. And as always, stay safe and healthy. Take care.